Welcome to the herd and thanks for listening. If you enjoy this sodcast, please like it, share it, give it a good rating, and follow, and help more people find their way into the ruminati herd. If you have suggestions for improvements, please let me know. Howdy, everybody. Thank you for joining us today for this episode of the Meet Your Herdmates sodcast. I'm really pleased today to be joined by Dr. Richard Teague. Thank you for joining us.
It's a pleasure, Peter.
Now, Richard, you live in Vernon, Texas. So for people not familiar with Texas geology, where is Vernon, Texas located?
It's exactly midway between Dallas and Amarillo, halfway to the Wild West.
And what kind of natural sort of eco-zone would that be?
It's mixed rolling prairie, medium rainfall, sort of 25 odd inches of rain, very variable as you can imagine, fairly lousy soils, a lot of encroachment from species like mesquite and juniper, and of course being drier country, it has suffered under over-optimistic management and just plain wrongdoing.
And so the 25 inches of precipitation, is that evenly spaced, or is it mostly in the winter? Or
it's bimodal with maxima in May and June. That's when 60-odd% should occur. Then another peak in September, and small amounts of rain, but allows a lot of growth going into winter. Because of the lower temperatures, of course, it's much more effective.
Interesting. And so if you had the chance, if we ran into each other at a social gathering and we hadn't met before, how would Richard introduce himself?
I was recruited in 1990 in South Africa, where I was doing research by Texas A&M University, because they had seen the research that I was doing on management to regenerate ecosystem in rangeland ecosystems, in particular grazing and related management to bring back the destroyed grazing and counter the effect of negative entities like encroaching bush.
And so you said overly optimistic management. Boy, we could apply that to a lot of things, but not the least of which is the Dust Bowl. Not too far away, if I'm understanding properly, from Vernon, maybe a little further north and maybe northwest.
We're pretty much in the center of it.
Yeah.
Between here and up in Oklahoma, sort of 50 miles north. And on any of those very sandy soils that were blowing a lot, they were totally decimated by the Dust Bowl.
And still, in many tracts, largely are today, as I understand.
Yeah, there's a lot of degraded rangeland, and a lot of things that we're doing, that the universities are doing, are actually, without their knowing it, actually exacerbating the situation by destroying the function of the soils in particular. And we are reversing that. We've been fortunate to locate through the NRCS, who's done all the soil mapping in our area and around the nation. When I first got here, I asked them to introduce me to the ranchers who had the highest soil carbon, because high soil carbon, the higher it is, the better any ecosystem is. So the guys who are doing a good job with that and succeeding economically are the people we've been studying. How did you actually improve matters, and how does it work for you economically? That's the core of our research.
So understand that soil carbon is well, first of all, it's not charcoal. It's a form of something we call organic matter, but that itself is an oversimplification, right?
Well, it's good enough to know that organic matter in the soil is fundamental, the amount of rain is limiting in a lot of agricultural situations, particularly the dry rangeland areas. But it's not the amount of rain you get that counts. It's the amount of rain that you get into the water, into the soil. And if your soil carbon is high, you get most of it in the soil. As soon as you destroy that, you create bare ground, then most of it runs off. So you can be getting 25 inches of rain, but only 10 could be effective. And that's the first thing you have to remedy to jumpstart everything and get it moving in the right direction.
And also, it's infiltration as well as holding capacity, yes?
Well, that's correct. And when you manage to increase your soil carbon, you also increase the amount of fungi to bacteria, which is fundamental to infiltration and creating good soil structure so that you get high infiltration and high hanging on to the water. And those two things, we've got chaps who've increased it from less than 1%, so around about 0.5% organic matter, up to 6% just with management. By stop doing all the bad things and allowing the plants to grow out before regrazing them again. Fairly simple, but it's amazing how people have just avoided doing the simple things.
So 6%, and to give people an idea, I seem to remember, I could probably find it in some of those books, that an acre furrow slice is like 2 million pounds plus or minus per acre. Is that,
pretty much.
And so 6% of that being this organic matter.
It's biomass. Mm-hmm. And the good thing about organic matter is that it has much more holding places for moisture and for cations, your soil fertility. So for a given size of soil, the soil is going to hold 8 times less than organic matter in terms of both moisture and fertility. So everything happens, improves as soon as you increase the organic matter.
So cations are positively charged nutrients, and the organic matter, soil minerals, but to a greater degree, the soil organic matter tend to be negatively charged, and therefore there's an attraction to hold the nutrients, prevent them from leaching. Okay. What is, you said 6% for some of these better, and that's a phenomenal improvement. What would be, if there is such a thing left anymore as native state, what would be the soil organic matter in these areas that you're referring to, these operations?
That's a question we'll probably never know the answer to. But in fact, in this area, that's getting close to, it might have been up at 8% in one stage. But if you go further north in the Great Plains, up into Canada, we've been measuring with fellows there who've pushed it up to 10, 15%, which we believe that's probably as good as it was again when the bison were actually running the joint. But we worked with guys for 15 years, and they started off at 1% or less, and they've pushed it up to those high levels just with management, which includes proper grazing and not putting stuff on the soil like inorganics and pesticides that kill the soil organisms that provide all the soil functional that you need. And all the research is done.
And minimizing the tillage, yes?
Absolutely. Just get rid of it completely. And we know how to do that. We've worked with all the guys who know how to do it, and we can cash flow it. And the improvement to their the function of their ranches and their profitability is extraordinary.
Now, in that part of the world, you worked across the continent. On these ranches, the tillage would have been to produce commodities or produce hay, or what would that have been for?
All the above. The basic fertility of the Great Plains was such that people moving from the east, where there was less fertility, came across. They could plant a wheat crop or a corn crop or something like that and have phenomenal yields. They just carried on doing the same, slowly depleting things. And then as soon as they started adding more negative factors to it, rapidly depleting the function. And that continues today. the really good thing is that we've worked with farmers and ranchers alike who've used soil regenerative practices to increase their function, water infiltration, fertility, to improve their profits and decrease their input costs enormously.
So the keys, well, I'm getting a little ahead of myself, mostly because I'm excited. How did you get interested in this space? How did you grew up in Zimbabwe? How did you get interested in ranching or soil ecology or regenerative agriculture or whatever it was called when you were a student?
My dad was a regional head of the NRCS, and I used to go to them as a youngster from about the age of 9 and go to farming places, the black and white folk, and see what they were doing to help them farm properly and improve matters. And those are the days when they still, instead of putting fertilizer on the ground, they were still incorporating legumes, cowpeas and things like that in amongst the crops. Very sustainable. And it's only later on they started putting the chemicals on that started causing damage. And I was going to go farming. And the politics you got totally out of hand in our country. And so I went to university to study grazing science at the University of Natal to learn the grazing, and I was going to go back to the farm and run the cattle business. My other brothers were involved with tobacco and coffee and flowers for Europe and stuff like that. But then everything fell apart, and I jumped at the chance to come across here when we had it.
So you've recently retired just a few months ago. Congratulations. And I'm just wondering, over the course of your research career, what are maybe some of the biggest surprises or paradigm shifters that you've personally experienced from the work that you've conducted?
The biggest surprises I've got is due to human behavior. I moved from Africa, which is supposed to be quite backward, and came across here and found out that limiting factors here were the same as over there, i.e. what's between people's ears. You get smart people wherever you are. You take a tribesman who's running his cattle and he's looking after his place. We grew up in a country where we learned how to do this really, really well. And my countrymen are some of the leaders right around the world in grazing now. And we learned it with the black folk we grew up with. But when you come across here, you find out that people are they're fixed in the way and they follow what Granddad did. Or, if they go to university, where do you earn the most money in agriculture? And that is in selling stuff to farmers. And research, of course, is basically conducted by the monies involved in, like in pharmacy, producing stuff that farmers buy supposedly to improve the profitability of their operations. But one of the things that characterizes a lot of agriculture is people do not study the unintended consequences of a lot of the stuff that they preach or push forward as the best way to manage. And, we had 3 years ago, I believe, we had the UN Year of Soil. And it became evident because all the soil scientists in the world just got up on their high perch and just said, guys, if we carry on like we're going now, we will run out of functional soil within 60 years. And that is a very sobering prospect. And that's why we started looking. We went straight to NRCS and said, show me the guys, introduce me to the guys who have been increasing the organic matter. And we've worked right around North America, finding those people, and it's amazing how successful a lot of them have been.
Well, and as I have sometimes said, there's no adaptation to a loss of topsoil, right? You can arguably talk about adapting to climate shifts, but without soil, and we can't eat raw rock,
Amen.
then it's over.
It's we've done quite a bit of work at a higher level. We work in a system framework. We study from the soil itself to the soil microbes, the relationship between the plants that we manage, either crops or grazing plants, and the soil microbes, because that has to be a working partnership that both actually benefit from in order for us to harvest sustainably from animal or crops in order to make a living and feed the nation. So we study all those all the way through to the macroeconomics. And one of the key things we do is we look at life cycle analyses, i.e. calculating the carbon footprint of different ways of doing agriculture through any likely food chain. If you're producing corn, okay, what's the food chain, the carbon imprint of ploughing and putting fertilizers on, and transport, compared to, okay, let's do it differently, like the guys or the Rodale Institute. They can put carbon in the soil and still make a much higher profit. And one of the things we're learning in the process is it's never maximizes profits if you're trying to maximize yield. If you manage to maximize your soil carbon, that is the thing most closely related to highest net profits.
Well, and I remember from the people that taught me, and it wasn't from that perspective, but it was saying, okay, you can increase your yield, you can increase your animal performance, you can reduce your cost of production, which is the most powerful lever that you have. And the cost of your production is the one that the operator has the greatest control of. You can market differently, but you don't control the market. And if yield alone is not the guide to profitability, I remember hearing, it may have been sort of anecdotal thing, but the farmer in Illinois that said, I'm going to raise 300 bushel corn and I don't care what it costs. Okay, so that's not a business. That's bragging rights. That's a lifestyle of some sort, but it's not a sustainable
it's mining
enterprise.
Yeah. So in fact, that brings us to another thing. How do we get to this kind of situation? Well, if you look at the funding and research goes for generally 2 to 3 years. Mm-hmm. So you can do a whole lot of bad things that have an immediate positive effect. But if you carry them on for any length of time, they can start absolutely poisoning the system. And it's quite sobering. When I was a school kid, before I even went to university, I used to read a lot of my dad's books. The books from prior to the Second World War, when they had all these chemical fertilizers, the biologists, the scientists working then were saying, if you go with those things and put them in your soil, you will kill your soil, and you will, within a decade or so, you will run out of functional soil. And we've gone ahead and done just that, even though they were warned to do it, because people are making money.
As a forage person, I mean, that's my sort of box, whatever. A lot of the cover crop species are short rotation forages that used to be part of a rotational pattern. Now, correct me if I'm wrong, or maybe you don't know this and we'll go on to something else, but I seem to remember something about British ley system, and that a lot of the capital that drove the Industrial Revolution was the production of the increase in productivity of British farming systems when they figured out that clover in rotations as they went around to grain to whatever the crops were, but that increased yield, increased their profit, and that capital had to find some new home, and so it went into other things. That
is absolutely correct, and Britain wasn't the only place. All of the European countries were doing the same, and that original concept goes back to prior to the early Romans, their agriculture. was based on those basic principles. And we're relearning that stuff now. The Australians are doing some really innovative work now with slight modifications of that. They've got their own, in the subtropical environments there, they've developed their own ley systems along the same principles, just using the species and modifying them slightly for the climate. But also, a guy who's a friend of mine now, Colin Seiss, he's a farmer in New South Wales where they get similar rainfall to what we get. And he has found he's got regenerative management of his native grasses. We're rotating them fairly quickly, and he's built up his soil carbon enormously. And he's got to the point now where he takes a quarter of his ranch and he overseeds in fall. He grazes heavily with his flock, and he overseeds with a winter growing plant or a mixture of plants to have the same effect on the soil as those ley crops. He also gets a green bite in winter, decreases his cost of supplementation. And then when that grazing is finished, you graze it short again so the winter growing species don't rob the oncoming summer growing grasses in spring, and then resume grazing on that area again at the end of the rotation cycle. So he's maintaining the strength and the health of the soil created by the perennial grassland. And because they're growing for another 3 or 4 months, a greater number of grazing days, they are pumping carbon into the soil over and above whatever happened in nature before. So he's achieving spectacular increases in soil carbon and total productivity.
Several times you've mentioned the microbiology, but there's macrobiology as well involved under the soil or in animals that live, burrow, and etc. I've heard somewhere that the weight of the biology in the soil can equal the weight of the cattle grazing the surface. Does that sound right?
Often exceeds it. We've got a team of 20 scientists, 14 disciplines, working around the nation at the moment. And one of our sharpest guys is an ecological entomologist, Jonathan Lundgren, in South Dakota. And he's been doing a lot of work on dung beetles and things like that. And he's finding as soon as you allow the dung beetles to be as healthy as they can be, they dig holes in the ground which enhance your infiltration. They bury the dung, but they create a whole extra living space for many, many thousands of other smaller soil organisms that enhance nutrient cycling, the speed of nutrient cycling, and connections with legumes and things like that, just to enhance the general soil function enormously. And they just jump up productivity and infiltration hugely. That nothing that we do can actually be as effective as what nature can actually do.
Well, I was just spending a little time earlier looking at, first in the beginning were grasses, right? I mean, first came the grasses. 60 million years ago, something like that, 55, 60, there seems to be a little debate, but a while ago. And sometime later then came the ruminants, and much, much, much later came the primates, and then much later came Homo sapien. So these systems have been in place, and the ecology responded to the niches and to the opportunities, and here we come. And so we're going to do better. That's an interesting concept.
Yeah, our research scientist group, yes.
And is there a name to that group, or?
Well, it's the Carbon Cowboys group. And if you want a really good 15-minute brief introduction to what we're doing, just go to Carbon Cowboys in YouTube. And the guy who's leading our thing is actually a movie maker, because we figured out that through our normal channels of getting information through to people, we're very ineffective. So he came along and said, let's make movies of all these things we are doing and work in closer partnership with the farmers who actually are doing a good job, and document what they're achieving and how they are doing it, and use that as our platform to get other people to have the same benefits.
I absolutely agree. If there's a benefit that can come from 2020, it's forcing people to re-examine how we've always done things in extension, in research communities, what have you, finding new ways to communicate information. And part of my mission is to build bridges between the various communities, because we're not trained to think systematically. We're not trained to think holistically. We're trained in our silo. And the more advanced your training, the higher the silo, but the greater the gaps between all the associated subjects. And so there's a lot of information that doesn't even cross to other disciplines, let alone become more widely available to the public.
That is absolutely true. And, it's one of the reasons why we've got so many problems at the moment, is we've got these super specific and focused research projects that do not consider anything but the narrowest sliver of ecosystem they're dealing with, or in a human health point of view. You have to look at what's happening to the whole body, because there's all sorts of things going on. There's a complexity there that you have to respect and know something about. And actually look for unintended consequences so you can avoid them. And we have to move to that. And by working with a number of people together, you can do that. We're looking at our bits of research and we find nice things here, and there. And then the guys say, yeah, but what you're saying over here is actually causing problems here. And suddenly there's a whole lot of new learning coming out that you wouldn't have found out unless you were working together like that.
You had mentioned earlier the time frame for funding, also the time frame for success as an academic researcher, is shorter than the meaningful time for some of these systems to be meaningfully examined. That's my perspective.
That's absolutely critical. In the kind of area we're in now, if you go and change your grazing or cropping behavior, it'll take 10 years of that kind of management before you can get a statistically sound difference from where you started. So you've got to have things going for that length of time. If you go to a dry area like New Mexico, where they get half the amount of rain that we have, you've got to go for 20 to 30 years if you're changing to a supposedly better way of doing things before you find out, okay, what's actually happening with this? What are the different things that are changing with that change in management? Conversely, if you go across to a wetter area, like we've just done across the Mississippi, we've looked in Kentucky, Tennessee, North Alabama, South Alabama, Mississippi, finding pairs of ranchers, conventional guys, and then the kind of ranching we have, adaptive multi-paddock grazing, which has a more beneficial effect on soil health. We studied at each one of those locations, and we're now coming up with all these disciplines. That's what you've got to do. We've picked up big changes within 3 years because, and then this is one of the things we're finding out, in order, you have to gear yourself to the amount of resources in the ecosystem. If you've got a lot of resources in the ecosystem, you can get a very quick response. But as soon as you go to a drier area where there are less resources, less moisture, less fertility, you slow down completely. So you need to organize your research along those lines and take that into account. That's one of the major things that's been missing. Also, in a ranch, if you do an experiment over 10, 15, 20, even 100 acres in this dry country, that has no meaning for a 15,000-acre ranch. It has zero. In fact, you're learning things there that would be the exact opposite response in a larger area. And we've conducted that research and published, and to show people you can't do this. You've got to take into account many, many different things to fully understand what's happening.
way back when I was going through school, the thought was, okay, we have these wonderful plants called legumes. We have these wonderful bacteria called rhizobia that form this symbiotic relationship, and you get nodules on the roots of the host plant. And thanks to those microorganisms, they can take night N gas, inert, the majority of the atmosphere, convert it into a form that the plant can use, and then it enters into the system. My training then said, but only once the plant decays or an animal grazes it and deposits it as urine or dung. And I just saw a presentation where somebody had basically constructed an H kind of thing out of pipe, and they had plants on grass on one side and legume on the other side, labeled N2 over here, and it showed up in the grass, and it was root transfer. Now, not a lot, but
the plants communicate among themselves, but also among all the soil microbes, the fungi and the bacteria and archaea that live in the area. They're all connected, and you can operate things in an optimal manner where all of them have an additive effect positively or an additive effect negatively. So you just got to figure that out. So fungi, for instance, they've got very small little filaments. They can extend the volume of nutrients available to plants many hundredfold. And they have the ability to actually drill with chemicals, drill through existing rock pieces. The plants can never get to that stuff, but they can. So as soon as you've got a healthy fungal population, they do the same with water. They've got such a dense fibrous matter in there that they can hang on to any water that comes in. They also they improve the structure so that you maximize infiltration into the soil, and they hang on to nutrients as a consequence. We're just beginning to learn how all these things function. Mm. And for a person like myself, that's why I got into this game, is to find out all the neat things that happen in nature.
Mm-hmm. I think that people will frequently, when they hear of, I'll just call it grazing mismanagement, to cast the net broadly. Mm-hmm. When people think of that, they think of overgrazing. They think of, that. And I don't think people are aware of the need for periodic defoliation in grasslands. Appropriate.
Now we're getting there. Yeah. This is at the hub of, grasslands are all our major water capture areas for cities and for people, as well as growing all the food and stuff. So having healthy grasslands is absolutely fundamental. So a healthy grassland, there has to be enough green material in the foliage of the forages to capture energy, which then feeds the soil microbes, which actually makes more water and nutrients available to the plants. And the animals come along and they graze it, and that enhances the cycling. So it goes through the animal onto the ground, and then more quickly gets back in a form that can be picked up by the plants again. As soon as you do not graze, the plants grow up, they shade each other, no energy or very low energy capture. So you're not feeding the fungi, you're not feeding the bacteria. It slows everything down. It decreases the amount of moisture getting in the ground. It slows down the nutrient cycling to a very low level. The whole function of that area slows down. The insects disappear. It decreases pollination. And when you bring your grazing, where you come and you graze the right amount, you get off it until the plant's recovered again. That keeps all those things functional. The capture of energy, the moisture getting in the ground, and you need to manage to have multiple species, because all the species growing together communicating amongst each other and enhancing overall function in the soil, that's what makes a really healthy system that actually benefits a whole life on Earth. And that is why the more carbon you got in the ground, the better it is for any one of these ecosystems.
There's this thing called ecosystem services that is a category of benefits to society for which the rancher or the manager is not compensated, right? They're producing beef or live animals because it's more than meat alone that's produced when we produce beef. And the benefits to wildlife, the benefits to water quality and water supply and fire suppression and aesthetics, and just ranks that food production activity above the commodity agriculture of row crop, monocrop, what have you. And yet we find these conversations, which I think I mentioned earlier, that if you want to take it to an absurd level, then you just say, well, let's grow sugarcane so that we'll get the most calories per acre. Well, there might be some issues with that I could think of, but what do you see as the future of society valuing these ecosystem services and incentivizing them appropriately?
Well, we're working a lot on that. And the first thing is to find out the farmers who are doing a good job, to document those, and then calculating the benefits that accrue. And literally 10-folds to 100-folds of increase in value to Homo sapiens and life on Earth accrues from having healthy ecosystem services. And this is where, I'm not for farmers or against farmers, but we have to manage well so that we all prosper and we all are healthy. So if farmers think they're doing a good job when they're not in fact doing a good job, in other words, they're not grazing properly, they're doing themselves and everybody else a disservice. But the fellows who are improving, and we're trying to develop systems now where they get, when we calculate how much we need to pay these folk to actually get managing better, it's when you're on that path that things are going to start improving. So the first thing is they're starting out now with paying people for putting carbon in the soil, which is good. You don't really want to concentrate on one thing, but improving carbon improves so many things that's a good place to start. And then what's associated with that, of course, is water. What happens to carbon in the soil also happens to water. So if your carbon status is good, you're capturing a lot of water, you're retaining water, and you're producing clean water from there. So those are things that naturally just spring to mind. And we really need to have a better reward for the people doing a good job than we do presently. It's fundamental.
We've been through, certainly for 50 years and arguably longer, going through this period of specialization in agriculture, where in North America, where we separate livestock enterprises from cropping enterprises. And there's still an overlap, but they have, in many parts of the country, you can drive for miles and not see a fence. And yet, I've said it before, I'm tired of the us and them. It's only us.
Yeah.
There is no plant agriculture without animal agriculture. And so as we look at farmers who are trying to improve soil health, it's my impression that the greatest gains will be made when they can get animals reintegrated into those cropping systems. Is that something you'd agree with?
That is exactly what we're finding. When you go and you look for the farmers who put the most amount of carbon in the soil, the very highest carbon levels have been where people have intelligently, in rotation, got your crops in rotation with livestock, with multiple species of livestock. But you also need, in the grazing thing, the adaptive management where you graze and then you let recover. And that's what allows deeper rooting to develop, which causes greater carbon at greater depth for greater benefits of the next crop that comes along. So you can grow a fantastic cash crop after you've had it under permanent pastures without putting anything in there because it's so fertile. One of the things that we're finding from our study east of the Mississippi is the conventional ranchers were grazing. They would put university extension levels of fertilizer on there, just moderate amounts of nitrogen and phosphate and potash if it was needed. And they would graze it constantly all the time. The guys who were doing the adaptive management didn't use any inorganics at all. They generally didn't put any even organics on there, but they just grazed the grass to the right degree and allowed it to recover before they grazed again. They didn't use any chemicals that would kill the microbes in the soil. And this is after 7 years, the mean of all the farms we looked at, 7 years. The amount of carbon in the soil on the adaptive management was higher than on the conventional agriculture, but also the amount of nitrogen was higher there, even though they never put nitrogen on there. It was totally biologically generated. So, you look after the biology and it makes things work. And that's what we've got to learn how to do better again.
So somebody described grazing as well, first of all, we're growing grass, which this grass doesn't have a direct economic value. Arguably, you could make hay out of it. For the most part, it has to be converted into a product that you're going to sell. That's the first challenge. The second is it's growing. You're going to come in and you're going to rip all the solar panels off. And now that plant has to regrow solar panels, which it does from its battery. But in a lot of these grasses, the battery is itself exposed. And so if you remove too much, you not only take off the solar panel, but you remove the battery. Or if you come back and graze it again too soon, then the battery has been drawn down, but hasn't had a chance to recharge yet. Does that analogy work for you?
Very well. And in fact, what do you learn from that? You learn you don't graze it below a level where it will quickly replenish, so you don't have to wait too long, but you're still allowed to grow long enough because when you graze it, if you graze it heavily, you cause sloughing off of the roots. So the plant can now maintain itself with the less energy from the leaves that come in. So you decrease the amount of root biomass there. If you do that too frequently, you make the roots very shallow, and so they can't handle droughts or anything like that. But if you allow full recovery, you recover the solar panel as well as the deep rootedness that allows you to handle the droughts and go deeper for nutrients. So you get the right combination there. It's like investing in an account that's giving you 12% instead of a 1% return on the capital you put in there. Literally as simple as that.
So if somebody thinks that they're going to set up a rotation for grazing, where every 3 weeks throughout the year, they're going to be going across their property and coming back to the same place again, versus the adaptive management grazing that you have in mind, how would you begin to try to educate somebody that it's not like the every 3 weeks?
This is why in agriculture, we have got to partner with everybody involved in agriculture. The better farmers, the guys who are doing it already, are the best people to learn from because they know how to manage the biology. They also know how to manage the cash flow and the profitability. And mostly academics, they're too narrow to be able to help with that. So researchers need to work with those folk, and that needs to be the platform that the farmers learn, should they want to, how to do it differently to gain all the benefits. And that's what we're setting up now with this movie maker. Peter Bick is the guy who's the movie maker. And your readers should look at Carbon Cowboys just to see what he does. He does a spectacular job of learning from everybody, speaking to everybody, and getting that together. And when a farmer hears it from another farmer, now he's got belief because that guy has done it. And many of these folk were suffering from recurrent droughts, and they were doing all the wrong things by killing their soil. So eventually they couldn't go to their bank managers. Their bank managers said, "You're too much of a risk." So they had to learn to do it without any of the expensive purchases like inorganics and pesticides. They had to use those old methods where they restored the biological function. And all the people who've made it work have been through that. And they've come out the other end ahead of the curve.
Mm-hmm. So you mentioned earlier about the water catchments for urban areas. You know, one of the many predictions of the world of 2050 is that globally over 70% of humanity will live in urban areas. So there's another issue for people to consider, the value of grasslands. There's been a lot of justifiable concern about deforestation, and I'd like people to consider whatever we call the degrassification of the grasslands. We need to come up with a new word for that. But the conversion of grasslands into cultivated agriculture. So if we look at the grasslands of North America, which I think is the largest natural biome in North America, how much of that has already been converted?
Well, you can get it back again. We know people who put it back. You get it back to permanent grassland. Permanent grassland. You see, the other big thing in agriculture, we get vilified for having livestock because of the emissions. Okay, but if your animals are feeding on perennial plants, the perennial plants are sequestering more carbon than the emissions from the animals that are eating them. You can grow crops in a manner, do it all the time without breaking the soil so that you don't get rid of carbon. And you can do it in a manner like Rodale do, and many, many farmers we work with, of a net sequestration, a strong net sequestration of carbon into the soil while producing crops very cheaply and minimizing pesticides and things like that. So straight away, we know how to do this while increasing the amount of carbon sequestered into the soil. Yeah. And it's not just climate that benefits from that. There are all these other ecosystem services benefit too. And it makes more money for the guys who are doing it.
And at the same time, and you and I have spoken about this before, we're producing a product, animal source food, that humanity requires, period, full stop.
Now you've started another line of business that's really important to deal with. So when you've got soil that is very strong biologically, there are elements in there that are producing micronutrients for your crops and for your animals that are eating that are not present if you're just tossing N, P, and K on there, where you get rid of all those micronutrients that make for healthy food. And there's a huge amount of information now on human nutrition and animal nutrition, that if you have got a biologically raised crops that have got the extra micronutrients in it, they are much healthier.
Well, I think we've spoken about this before. I'm most concerned at this point with hyperinsulinemia and insulin resistance, and I'm somewhat familiar, and I just keep saying until we've addressed the 88% of the public, adult Americans, that suffer from this, and it's probably similar globally, then these other issues I don't think are the best investment. We could perhaps agree to disagree on that. The point is, today in the world, 59% of children 6 months to 23 months don't get any animal source food. And everybody agrees they need it. Well, virtually everybody. I know there's some who want to believe that animal source food is not essential for human flourishing and proper development. But I'm sorry, that's sound well established. So what's the cost of having malnourished people in terms of economics, in terms of societal, in terms of environmental? Right now, the healthcare industry is a greater economic impact than farming, let alone looking at the smaller portion that's animal agriculture. So it's absolutely critical that we get the farming systems oriented properly, but that requires a pull from the other side where the policy is no longer saying, don't eat that red meat, that's bad for you. Right. So what are we going to eat? Well, we're going to eat soybeans. We're going to eat corn. We're going to eat all this. Well, how are you going to? No, I'm sorry. We have to get that sorted.
Yeah, the first thing we started off talking about is getting our land management right, where it's a sustainable use of land. But then you get into the situations we've got now, where so-called people are developing so-called solutions with fake meat and things like that, that actually are going to exacerbate those situations, because they've got a much bigger carbon footprint than the sustainable, the regenerative stuff that we've got on now. Plus, they haven't got the nutrient density that creates healthy humans and healthy animals. That's exactly what you're saying now. Mm-hmm. So there's a whole lot of areas that are dry, like what we live in now, where the people have to make a living off the land, no matter what country they're in, and using the natural resources with grazing animals. Now, as long as they do it properly, so the ecosystem services are there, yeah, that's going to work. You can do it in a way that actually ruins the system. We've got to get away from that. Mm-hmm. But if you come to cropping areas like the Corn Belt, we can actually introduce more. You can have completely perennial plants there using what I mentioned earlier, Colin Sice, having pasture cropping. You grow the crops, like in the ley system is exactly the same. You have the permanent crops growing pastures growing for a number of years, managed well, so they're improving the fertility. Then you skip a couple of years and you have crops, one set of crops after the other, which costs nothing. It doesn't ruin, it might use a bit of the fertility, but you've got the much broader based fertility because it's a biological fertility. And that improves the human health and also decreases the carbon footprint of agriculture. So you can manage in any particular environment to get the right balance of all those elements to earn a good living and make people healthier as a consequence.
And contribute these ecosystem services, these benefits to society in addition, as if the food itself weren't enough. But another aspect of nutrients in these different systems is when I ship cattle from area, I remove less nutrients from that area than when I harvest corn or soybeans or hay and move it somewhere else. And when we're talking about humans living in urbanized areas, I'd like somebody to start looking at how the more digestible forms of nutrients in animal source foods might impact the water treatment requirements, as opposed to feeding a population on these more plant source foods that end up being less digestible.
Yeah, and to add to that, if you're growing the things like our adaptive management are versus the conventional guys who are putting inorganic fertilizers on there, your clean water that comes off the area that has biologically derived fertility, not added inorganics, that just adds to the clean water and clean, more healthy food.
Mm. So you've retired. Again, congratulations. I'll turn 65 in August, but not for a few years yet for me. What's next now? You're continuing in this research.
I was involved in quite a few teams, and I'll carry on, communicating with them. We've got a whole lot of publications that are in journals now or have just come out So it'll be a bit of continuing that. But I never wanted to do anything else in life other than go farming myself. But politics precluded it. So I'm in the process of buying a farm now, and I'm going to manage it regeneratively. And my kids are interested in it. And so that's part of it. We teach the next generation, 2 generations, about a better way to do things. And we can grow our own healthy food and just be part of the solutions to all these serious problems we face.
Absolutely.
Plus, you've got to keep busy. Otherwise, you just get old and crotchety and start whinging at things.
Yeah, you start growing things. It's not good. Well, that's great. So in addition to soil cowboys, carbon cowboys, where else would you direct people who wanted to learn more?
Alan Williams works together with a whole bunch of people. Just Google for him on YouTube, and you'll find it's the Soil Health.
Is it Understanding Agriculture is one thing?
That's it. Yes, okay. That's the publication that comes out to people. That group of people are astoundingly good, and they are the leaders in this whole deal, and they deal with cropping and with grass-fed and grass-finished. And those are the go-to people at the moment. We just need each one of them to undergo binary fission or whatever it is, to have more of them around. But this is it's based on people managing the land, so the successes are there for everybody to see. They just go in that direction.
Wonderful. I'll also put some links to some of your more recent papers or papers that you've been on so that people can see those in the show notes. It's great to talk with you. It's been, like I say, a long time since we were last together, and that was in Guelph, Ontario, I think.
Yeah, that was a really good meeting.
Yeah. Yes, it was. I still use some slides with some of your quotes, so I'm a shameless leverager.
Anything that I do, I share with people. If they can use it and benefit from it, I'll be very happy.
Perfect.
Yeah.
It's only fair to open myself up to any questions that you might have. Otherwise, thank you for your time.
It's been a pleasure, Peter, and we keep in touch.